కన్ఫర్మ్ చేస్తారా?
క్యాన్ తెచ్చింది పన్నెండప్పుడు తెచ్చేయచ్చు బాగా ఎండ ఎక్కడ
Welcome dear students. Today we discuss about the uses of beats, and also I'll explain some problems based on the beats concept. Okay, so let us come to the point. Here in the last class I had explained about beats, and beat frequency is nothing but it is number of beats heard per second. Beat frequency is n1 difference n2. It is equal to number of beats heard per second. So using the concept of the beats, we can determine the unknown frequency of a given tuning fork. So first I'll explain how to determine the unknown frequency of a given tuning fork. For that, already I had given some theoretical concept to you, that keep the 2 points in the mind. When you consider a tuning fork, when it is loaded with wax, the inertia of the tuning fork increases, means it will complete less number of vibrations in a particular time, means its frequency decreases. Means when loaded with wax, the frequency of the tuning fork decreases, but when filed, when a tuning fork is rubbed or filed, right, its frequency increases. So due to filing, frequency increases, and due to loading with the wax, the frequency decreases. So with using this concept in the mind, now I will explain how to determine the unknown frequency. To determine the unknown frequency of a given tuning fork. So for this, first I will consider a tuning fork A. Its frequency is forks side by side, and if they are vibrated, what happens? There is a difference in the frequency. Means when they are vibrated, say 4 number of beats are produced initially. The first problem is, first I will vibrate these 2 tuning forks. When they are vibrated and when they are placed side by side, say 4 number of beats are produced. So number of beats produced is 4. So the frequency of B is, so I'll write here, when they are vibrated together, let us consider 4 beats are produced. 4 beats are produced. when they are vibrated together, how many number of beats are produced? 4. Means the frequency of B must be, therefore the frequency of B can be written as, the frequency of B, it is, can be written like this, that is, frequency of B is, it is either 512 plus or minus 4, means it is 516 hertz or it may be 508 hertz. There are two possibilities. Why? Because what is meant by beat frequency? Beat frequency is nothing but it is the difference in the frequencies of A and B. So if it is 512 hertz, if they are vibrated together, 4 beats are produced, means the frequency of B, it is more than this, more or less than this A, means the difference in frequencies must be 4, nothing but frequency of B, either it may be 516 hertz, 512 plus 4 or 512 minus 4, nothing. There are two chances here. The frequency of B may be 516 hertz or 50 hertz. So we have to determine which of these two is correct, because we have two chances. Here the answer may be either 516 or 508. So in order to confirm them, again what I will do is I will take the unknown tuning fork and I will load this with wax. So I will write here, when unknown is loaded, when unknown is loaded with wax, unknown is loaded with wax, now when vibrated together, only 2 beats are produced. Say I have taken 2 beats are produced per second. So keep this very important point. When unknown is loaded, when unknown is loaded with wax, when unknown is loaded with wax, how many number of beats are produced when they are vibrate together is 2. Say let 2 number of beats are produced. So then what will be the new frequency of B? The new frequency of B after loading, okay, after loading, when after loading, the frequency of B can be written like this. It is producing after loading, it is producing only 2 beats, means here the frequency of B must be either it is 512 plus or minus 2, nothing but it may be 514 hertz or 512 minus 2, nothing but this is 510 hertz. There are two chances. See this. The frequency of B after loading, it may be 514 hertz or 510 hertz. So this is the example I have taken. See, I have taken that this is a tuning fork of known frequency. B is a tuning fork. Its frequency is unknown. First what I have done is, when they are vibrated, I have given that 4 beats are produced. When 4 beats are produced, the frequency of B may be, it is 512 plus or minus 4, means 516 hertz or 508 hertz. See, means frequency of B either it is 516 or 508, but it is difficult for us to confirm which one is correct. For that, I have taken, what I have done is, I have loaded the unknown tuning fork with wax. When unknown tuning fork loaded with wax, what happened again after when they are vibrated, how many beats are produced? Two number of beats are produced. When two beats are produced, see this, the frequency of B after loading will be either 512 plus or minus 2 means it is 514 or 510 Hz. Now, this is the frequency of B after loading. This is the frequency of B before loading, actual frequencies. Now you compare these two better. Compare these two means 512 means added values, plus values. 512 plus 4, 516. Okay, this is 512 plus 2, that is 514. When you compare these two, this indicates, if you consider 516 Hz is the frequency of B, 516 Hz is the frequency of B, then what happens? After loading, this 516 becomes 514 after loading. Nothing but what is happening, the frequency of B initially before loading 516, after loading it becomes 514, means when B is loaded with wax, what happened here is the frequency is now decreased from 516 to 514, means this is the right answer now. So the actual frequency of B is 516 Hz, but you come to this 508 and 510, you compare these two. When you compare these two values, subtracted values, before loading, if you consider 508 is the frequency of B, after loading what is happening, 508 becomes 510. 508 becomes 510 means after loading here it is indicating that the frequency is increased, but it is not the case. What happens, what we learned already, that when any tuning fork is loaded, its frequency must be decreased. We have unknown, B is loaded. This unknown is loaded with wax. See that, unknown is loaded. When unknown is loaded, its frequency must be decreased. It is unknown frequency. Before loading, it is 516. After loading, it is 514. Means 516 becomes 514, means now this will be the right option. So therefore you can consider that the frequency, actual frequency of B is, this is 516 Hz. This is, in this way we can confirm we can determine the frequency of B. Very simple to understand. See that. I'll explain another example so that you can easily understand. But this is the model, that when unknown is loaded with wax. When unknown tuning fork is loaded with wax, its frequency should be decreased. 516 decreases to 514. But it is not the right answer, because it is before loading it is 508, after loading it becomes 510, means here it doesn't satisfy. Right? It is the wrong option. So the correct frequency of B is, it is the right answer. This is 516 Hz is the frequency of B. So to have some practice, I will write a problem first, then I'll explain this. This is one model, just keep this in your mind. Now I will change this model. I'll take another example so that you can easily understand. So now first I'll write the problem, right? Try to understand this. So I'll write, suppose I'll consider a problem like this. See this. Okay? The frequency of a tuning fork capital A is 480 Hz. Okay? When it is vibrated with another tuning fork B, it gives 3 beats per second. When it is when the tuning fork B is filed, when the tuning fork B is filed, 2 beats are produced per second. Find the frequency of B. So we can find out, see this, read this problem clearly.